Okay, lesson 8.6, the last part of our rational expressions chapter, and it is solving rational equations. So rational, if you recall, means something that can be expressed as a fraction. So we're solving equations that have fractions, which, nothing new, you've done that. As you look at these, though, they're rational expressions. They're fractions. They have variables in the denominator, and there's a lot there, isn't there? So we're going to go over the technique of how to solve that. So if you read there, let's see. A rational equation contains at least one rational expression and one equal sign. Hey, it's an equation, and it contains an equal sign. The easiest method to solving these problems is to clear the fractions. Okay? Anytime I teach an equation with solving an equation with fractions, one of the options I'm going to give you or suggest is to clear the fractions. And you'll notice we're going to do that by multiplying both sides by the common denominator. So for the third lesson in a row, I'm still going to be asking you to find that common denominator. It's not necessarily that we're getting a common denominator. We're going to use that to clear the fractions. We're going to multiply by the common denominator. Those denominators cancel out. And then you just have a traditional algebraic equation where you might have to distribute, add, subtract, maybe FOIL, maybe, multiply. It just, depends. Okay? And then, notice one other key detail. We have to check our answers. Because what's true about a fraction, guys? What do we know about the denominator of a fraction? It can't equal 0. And when we have x's in the denominator, we run the risk of that denominator equals 0. So we do have to check our answers. Checking our answers will just be making sure that what the typical restricted value, how we've been finding those restricted values the last 2 lessons, just making sure those restricted values aren't what any of our answers came up to be. Okay? So, let's look at example 1. What are the solutions? X over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. As we've been dealing with fractions the last couple of lessons, what have I usually had to start off doing with those denominators? Factoring them. Like last lesson, when we were trying to add and subtract, we couldn't really add and subtract and get that common denominator until it's factored. So, do any of those denominators factor? X squared minus 9 factors, yes? Is this old news? How does x squared minus 9 factor? 2 parentheses. Remember your difference of squares? Square root of x squared is x, so x times x. The square root of 9? 3. And what about the signs when it multiplies to be a minus 9? A plus and a minus. So that denominator of x squared minus 9, you read that, I hope, is x plus 3 times x minus 3. So now, take a moment and examine your denominators. And ask yourself, if I was getting a common denominator, what would be the least common denominator? So what would it take to give every fraction the same denominator? And in this case, we're working with not 2 fractions, but 3 fractions, right? Is there anything that all 3 fractions have in common? No. I would start with, is there anything that all 3 fractions have in common? There's nothing that all 3 fractions have in common. Is there anything that 2 fractions have in common? Okay. The first and the last fraction both have an x minus 3. So since x minus 3 is in common in 2 of our fractions, that should be part of my common denominator. Anything else in common in some of the fractions? The second and third fractions both have an x plus 3, correct? So since that's in common, x plus 3 should be part of our least common denominator. Anything else I haven't used? Because that's the idea, is that any factor that's in the denominator has to be used. Have I used all my factors? Everything's covered? Okay. So my least common denominator is that x plus 3, x minus 3. So if you look back up above, what are we going to do with that common denominator? We're going to use it to clear the fraction, so we're going to multiply. So here's what I'm going to write out. Is that we're going to take this entire fraction, this entire equation, and we're going to multiply by x plus 3 times x minus 3. And technically, I'm just being lazy, I'll be honest. Technically, I should write that we're multiplying the left by that and the right by that. But did you notice I put my parentheses around the whole equation? Okay, I'm kind of being a little lazy there, but we're multiplying both sides by that. Now, some of you, once you see this, you get into it, you'll be able to jump right into your canceling and write out your equation. For the benefit of this being the first time through teaching, I'm going to go through and write out the equation. And next to each set of terms, I'm going to write this x plus 3, x minus 3, so you can see what's going on here. So if I write out my equation as is, which means I'm going to write out and space it out, x over x minus 3, plus, and then I'm going to leave a gap. I'm going to write x over x plus 3. I really didn't leave quite big enough of a gap in my mind, though. Forgot what I'm doing. I'll leave a little bit bigger gap so I don't have to totally squeeze in. So x over x plus 3 equals, and I'm going to leave another gap, 2 over x plus 3 times x minus 3. And I did this on purpose. You'll see why in a moment. So all I did is I've rewritten the original equation. Yes, I just spread it out. What are we multiplying each term by, each of those fractions by? X plus 3, x minus 3, yes? So in front of each term, I'm going to write x plus 3, x minus 3. So I'm multiplying the first fraction by x plus 3, x minus 3. I'm multiplying the second fraction by x plus 3, x minus 3. And on the far side of the equal sign, I'm multiplying this third fraction by x plus 3, x minus 3. Now, if we're multiplying those all by fractions, how do we make x plus 3, x minus 3 a fraction?
Over 1.
Over 1. And again, as I said, some of you are looking at what I'm doing and you're thinking, wow, that's a lot to write out. But you don't know where I'm going yet. Once you see where I'm going, some of you won't need to write that out, I don't think. Okay. Got it written out? First fraction. X over x minus 3, and we're multiplying it by x plus 3, x minus 3. What cancels? A factor of x minus 3 is on top and bottom and can cancel, yes? So what remains? A factor of x plus 3, a factor of x. So I'm going to write down below x times x plus 3. Now I'm going to carry down my plus sign that's between the fractions. Second fraction. X over x plus 3 times x plus 3, x minus 3. What cancels? X plus 3 cancels. What remains? X minus 3 and x. So I'm going to write that as x times x minus 3. Carry down your equal sign. Are you getting the idea of what I'm doing? Now I'm multiplying. It was 2 over x plus 3x minus 3. And I'm multiplying by x plus 3x minus 3. What cancels? X plus 3, x plus 3. X minus 3, x minus 3. What remains? 2 over 1, which is 2. Technically, all of these things could have been over 1. Okay. It looked ugly in the process. It took some work. It may still look ugly to you, but does it look better? Does that look like an equation that might be attemptable now? I mean, that's the idea, is once you get rid of the fractions, this should look more approachable. Like you shouldn't have to totally run and hide from this problem. Right? Maybe? Okay. Algebra skills. What do we do? Distribute the x's, right? We're going to do x times x times 3. X times x times minus 3. So write it out with me. X times x is x squared. Plus x times 3, 3x. Plus x times x squared. X times minus 3. Minus 3x equals 2. What'd you say? Okay. Yeah, do you guys see the like terms? We distributed, we got rid of all the parentheses, so now collect these like terms so we can see what's going on. What is 1x squared plus x squared? Or in other words, x squared plus x squared. Or if you don't like that, 1x squared plus 1x squared. 2x squared. What is plus 3x minus 3x? They cancel. That was nice of them, wasn't it? Okay. Equals 2. This problem's getting easier by the minute. If it's 2x squared equals 2, what do we do? Divide by 2. If we divide by 2, we now have x squared equals 1. Am I done? No, I haven't found x yet. I've only found x squared. What's that last step? Take the square root of both sides. The square root of x squared is x. What's the square root of 1? Plus or minus 1? I say it every time we do this, right? When you take the square root in an equation setting, you have to account for the positive and negative solutions. So we have x equals plus or minus 1. What do we need to do before we call this problem complete? Check. Now, here's the deal. I am not expecting you, and honestly it might be just as easy, but my expectation is not that you have to go back and plug these answers in. You can, okay? It might not be the most fun thing in the world, but that's not how I would expect you to check it, or necessarily expect you to check it. Option 1 is go plug them in. Option 2, what would be the restricted values? What is x not allowed to equal here? In this first fraction, x cannot equal 3, because if you set x minus 3 equal to 0, x cannot equal 3. What about this fraction? What can x not equal? Negative 3. This fraction? Positive or negative 3. Was positive or negative 1 ever an option or an issue? No. If I plug 1 or negative 1 into any of these denominators, is it ever going to make any of them 0? No. So that was my check. I didn't write anything down for my check, other than I just wrote a check mark to kind of as a reminder. But that's my check. That when I put 1 and negative 1 into the denominators, I'm not going to run into an issue. Questions? You got the idea of what you're doing here? Because essentially it's just variations on that to solve all these. All comes in, obviously some of the solving steps may be different and whatnot. Okay, let's go ahead and try B. You guys have what you need from A? X minus 1 over x squared plus 3x plus 2 plus 2x over x plus 2 equals x minus 1 over x plus 1. Thoughts on where to begin? If your denominators are not factored, you need to get them in factored form, right? Because if they're not factored, you're not going to be able to find your common denominator. What factors in my denominators? What factors here? Yeah. Does x squared plus 3x plus 2 factor? We hope it does, otherwise this problem is going to be really not very pretty. The last one wasn't very pretty to begin with, so if this doesn't factor, it makes it that much worse. Okay. X squared is x times x. I need numbers that what? Multiply 2, add to be 3. Well, what multiplies to be 2? 2 and 1. Start to second guess yourself. So it multiplies to be positive 2, adds to be positive 3, plus 2 plus 1. Coincidence that it's the same as the other two denominators? Not really. It's not that they'd have to be the same, but life sure is better when they're the same. Okay, does anything else factor? Okay. What would be my least common denominator? What factors can I use that will account for all denominators? X plus 2, x plus 1. Does that take care of everything? It does. So common denominators, x plus 2 times x plus 1. Okay. Do you remember? What am I going to do with that common denominator? I'm going to multiply every part of this problem by x plus 2, x plus 1. For the benefit of me teaching the equation and everyone at different levels, I'm going to write it out the long way. If you can see the canceling without writing out the long way, by all means, you can skip writing out what I'm getting ready to write out and just go ahead and do your canceling. Am I making sense when I say that? Okay. For the benefit of the masses, I'm going to spread this equation out so we can write what we're multiplying by on each term. So my first fraction, x minus 1 over x plus 2, x plus 1. plus, and I left a gap in front there. I'm going to leave a gap in front of this next fraction, and it's 2x over x plus 2 equals, I'm going to leave a gap, and it's x minus 1 over x plus 1. Am I on the screen? Hey, I'm on the screen even. Okay, what am I multiplying every single piece of this equation by? X plus 2, x plus 1 by the first fraction. X plus 2, x plus 1 by the second fraction. X plus 2, x plus 1 by the third. Okay. What do we know about this x plus 2, x plus 1 we're multiplying by? We can make them fractions by putting them over 1. Okay. First set, what cancels? X plus 2, x plus 1. That was fun. What remains? X minus 1. Plus. Second term, what cancels? X plus 2. What remains? 2x, parentheses, x plus 1. Carry down your equal sign. What cancels? X plus 1 cancels. What remains?
2x.
How about x plus 2?
Yeah, x plus 2.
And x minus 1. I know, I was trying to figure out what you did there. Okay, so my point for those of you that want to, could this green line I just wrote out, could you have made that your first line of work if you felt comfortable there? You can. Okay? I'm totally okay with that. If it was me working on my own, I definitely would. Okay. Kind of looks like a big messy equation, but anything's better than those fractions in my opinion. So, what do I do next? Yeah, do some multiplying, do some distributing. So x minus 1 was already good. It's x minus 1 plus this 2x is going to distribute. What's 2x times x? 2x squared plus 2x times 1? 2x. What about x plus 2 times x minus 1? We have to FOIL, don't we? Okay. X times x. X squared. Can we do outsides and insides at the same time? Are we that talented or not? Outsides are x times minus 1, which is going to be minus 1x. Insides, 2 times x, which is 2x. What's minus 1x plus 2x? 1x or x, yep. And lastly, 2 times minus 1. Minus 2. Okay. What can we do on that left-hand side?
Do we subtract x? Oh, I noticed.
Well, it's not subtracting, but put the x's together. Okay, like terms is what I'm going for here. If I go for like terms, put those like terms together on the left. And I'm going to organize as I go because traditionally, what term am I going to prefer to see first? That 2x squared. So if I keep the 2x squared out front, What do you notice about x's? X plus 2x is going to be plus 3x, and we still have a minus 1. And it equals x squared plus x minus 2. Thoughts where to proceed?
Add the 1 over and subtract the x squared and x.
What do we want our goal to be here? And I guess here's the big thing I would look at. Right now I have x squareds on both sides, yes. I have x's on both sides, and I have plain old numbers on both sides. When I start moving things around, are all three of those terms still going to exist? Am I still going to have an x squared? Yeah, because those aren't going to cancel. Am I still going to have an x? Yeah. Am I still going to have a number? I am. So if I'm going to have an x squared term, an x term, and a constant term, what do I need to make happen with this equation? What form do we usually work in when we have x squared, x, and a number? We usually make the equation what? What? Equal to 0, right? I'm going to have an x squared, a bx, and a c. So we want to make this equal to 0. In order to make it equal to 0, I have a positive 2x squared here and an x squared here. So the easiest thing to do is to move the x squared left, which means I'm going to subtract x squared, right? If I subtract x squared on the right, subtract x squared on the left. So at this point, that means I'm making my right equal to 0. So how do I move a plus x? Subtract x. Subtract it on the left. How do I move a minus 2? You add 2. If we add 2 on the left or on the right, add 2 on the left. What does this equation become?
That would be 2 plus.
No.
Wait, no.
2x squared minus x squared. Right. Think 2x squared minus 1x squared, which is 1x squared. 3x minus x. So think 3x minus 1x, which is 2x. Minus 1 plus 2. Plus 1 equals 0. What's next? X squared plus 2x equals x squared plus 2x plus 1 equals 0 is in a form where we can factor to solve this. Because, I mean, that's the idea, is how do we solve for x? Last time, we just had an x squared and a number term. So we worked out that we could just get x squared equals a number and take the square root. Well, this time, we're not that lucky. We have x squared plus bx plus c. And when we do that, we factor it into 2 parentheses. X squared breaks into x and x. What about these numbers? Yeah. Multiply to be 1, add to be 2. Multiply to be 1. My only options are 1 and 1. If it multiplies to be positive, adds to be positive. Everybody's positive. How do I solve this when I have 2 parentheses multiplying to equal 0? Set them both equal to 0. X plus 1 equals 0, or x plus 1 equals 0. Okay, I probably could have just done with setting one of them equal to 0, but what do we know? What's our answer? Yeah, or technically I should say what's our answers, but it ends up just being 1, doesn't it? So x equals -1. Because if it's x plus 1, you have to subtract 1. Final step. Check. Okay. We only have one answer to check, so that's helpful. What happens when you start checking the answer of -1? What happens when I put -1 into this fraction here on the right? -1 plus 1 in the denominator is 0. And can that happen? No, you can't have 0 in the denominator of a fraction. It doesn't exist. And so, if -1 doesn't work, it didn't check. What's true of this problem? My only solution that we had found just failed to work. So, what solution remains? No solution. And again, that's because if we check our restricted variables, restrictions on the variable, we would have found out right here that x cannot equal -2, x cannot equal -1. Well, we got x equals -1 as our solution after all that work. So, no solution. So be aware, be checking your answers. Okay? Okay. Where am I at on time? Okay. I think what I'm going to do is I technically only have one more example planned on the front side, which is E, but can I get that done in 6 minutes and not confuse you in the process? I could get it done in 6 minutes. That's a piece of cake. But what state would I leave you guys in? Okay. And now I'm down to 5 minutes because I talked, right? Okay, so before I finish though, look at C. We're not working C. What I want to know is on C, what would you multiply by to clear your fractions out? In other words, what would be your common denominator if you had to get one? There already is a common denominator, yes? So, my point would be that if we were doing this problem, we would multiply by x plus 2. Agree? Okay. Let's talk about D. If we were doing problem D, what would you multiply by? I don't have to factor anything? No, my denominators are already factored, aren't they? So we would multiply by x plus 1 and x plus 4. Okay? Follow my skip. What about F? What would you multiply by on F? Okay, look at your denominators. X minus 2, x plus 2. This one doesn't matter because it's not a fraction, right? We would still have to multiply by it. And so we'd be multiplying by the x plus 2 and x minus 2. Okay. We will pick up on example E tomorrow at the beginning of class. Homework will not be due tomorrow. I think if you go in and look right now, though, homework might be sure. So I will double check that. But we will tomorrow go back and finish E. I wasn't planning on doing any with the word problems on the back, but I'll check and see if I want to do any of those or not. And then that makes homework due on Wednesday. If you did not get 8.5 done, you might want to do that.